Hello everyone. So in this video, we are going to see a question that is related to RLC resonance circuit. Okay. And the data you have given, the resonance frequency of the circuit is 10 radian per second. And at omega equal to 15 radian per second, the input power factor of the circuit is 1 by root 2. You need to find out the quality factor of the circuit. Okay. So before we start this discussion, first of all, you need to know the you can say the current and the voltage relationships of a series RLC network. For a series RLC network, if you keep on increasing the frequency and if you check the magnitude of the current, basically it will be maximum at resonance frequency and then slowly it will decrease. Okay. And this particular frequency, we call it as a resonance frequency. And at this resonance frequency, your circuit power factor will be unity and the power delivered will be maximum. That means at omega is equals to omega naught, that means the resonance frequency at omega equals to omega naught, you are having the maximum current here. Okay, let me call this as a what should I call, uh, maximum current. Okay, so let me call it as I naught. This is the maximum RMS current. Okay, your I value here I am not showing the magnitude, but you can just, I think it is understood, like the magnitude is I naught, it is the maximum value. Okay, so in this case your power delivered will be maximum. P is equals to I naught square into R. Okay, there is something we call as a half power frequency. Okay, like the power you are getting at this frequency, you will get the half of that power at two different frequencies. Okay, this is we call omega 1, this is we call omega 2. And at half power frequency, at P is equals to half of the P max. This is my P max. It's the maximum power delivered. Okay, and at P is equal to P half of the P max, basically you are having omega is equals to omega 1 and omega 2. These two frequencies, at these two frequencies you will get some impedance, because of that you will basically get the half of the maximum current power. So you have this particular relationship P max is equal to I naught square into R. Now tell me at what condition your P max become half of the P max. That means if your I value becomes anyhow I naught by root 2, right? If your I is equals to I naught by root 2, in that case what will happen? Your power will simply become I naught by root 2 into R, that means half of the P max, right? That means the moment I am getting I naught by root 2 current, I'll be getting the half of the maximum power. Okay, and the bandwidth is defined as omega 2 minus omega 1, and this is called a half per frequency also, half omega 1 and omega 2. Now we have to find out the relationship, like what is the relationship between the power factor and or the half per frequency. Okay, now we will try to find out the impedance of the series RLC circuit. Impedance of series RLC circuit is equals to R plus j omega L minus 1 by omega C. What is the modulus of this impedance? The magnitude of the impedance is equals to R square plus omega L minus omega C. At any frequencies, the current should be at any omega. At any omega, your circuit current should be Vs by mod Z, right? This is the thing. But at half power frequency, your I should be I naught by root 2. What is my I naught? I naught is the maximum current. I naught is simply or the maximum current, that means current at resonance condition, and at resonance condition the reactive portion becomes simply zero. So Vs by R. Okay, so this is the I naught value at resonance conditions. This is the resonance. So if you just put this thing here, you will get I is equals to Vs by root 2R. This is one equation. And in general, the current equation is also I is equals to Vs by mod Z. And also at half power frequency, I is equal to Vs by root 2R. So that means, see, these two equation needs to be same, because at for any given frequency this should be the case, and half power at half power frequency this condition has to be satisfied. That means if you just compare these two equation, the mod Z should be equals to root 2R. Now if you draw impedance triangle, this is the resistive part and this is the inductive, the reactive part, that is XL minus XC. Okay, and this is the mod Z, and this is the theta, input power factor angle. So cos theta simply R by mod Z. Okay, if it from this particular relationship you see R by mod Z is simply 1 by root 2. That means at half power frequency my power factor is 1 by root 2. That means the frequency that is given to us 15 radian per second is basically half power frequency. Okay, now at half power frequency, and it is simply it is basically this frequency omega 2. See, because 10 radian per second is resonance frequency and omega 2 is 15. So uh, so omega 2 is given as 15 radian per second, and mod z is simply root 2r, and power factor is simply 1 by root 2, right? Now quality factor is simply, there is a relationship between bandwidth and quality factor. Bandwidth simply omega naught by quality factor. So quality factor is equals to omega naught bandwidth. So if you just put the values of omega naught and bandwidth and all, you will get the quality factor is equals to 1 by R root over L by C. Okay. Uh, and how to find out the bandwidth? So there is two ways you can go with, like either you can go with this, from this you know the resonance frequency that is 10, and the bandwidth, right? The bandwidth you don't know, but there is something that you also know, like the resonance frequency is simply geometric mean of omega 1 and omega 2. So geometric mean, so this is 10 is equals to root over 15 into omega 2. So from here we will get uh, 10 square by 15, you will get 6.67 radian per second. This is the omega 2. Sorry, it is omega 1. Sorry. It is omega 1, because omega 2 is known to us. So 15 and it is 6.67. So I know the omega 1 and omega 2. So I can comment on the bandwidth. Bandwidth is equals to omega 2 minus omega 1. That means minus answer plus 15. That is 8.33 radian per second. Now put this value here into 10. So you'll get 1.2 as a bandwidth quality factor. Quality factor is 1.2. I hope this discussion is clear to you, like how to approach such problem. And this is the basically important observation you can remember. But even though if it is not if you are not able to recall it, this is how you can basically derive it, how it is happening, what is half power, how to derive the half power frequencies and all. Okay, you can just go with the basics. Okay, but still if you have any doubt regarding this discussion, you can definitely ask me in the chat box. Thank you.